Just when everything appeared ready for a safe touchdown, an invisible force violently struck from the sky. And what happened next? Well, it reveals far more about the fragile dance between human intuition and aerospace automation than anyone expected. Welcome back to The Explainer. You know, a modern commercial airliner is basically one of the most technologically advanced machines in human history. It's governed by millions of lines of code designed to prevent disaster before it even begins. But what happens when the very systems built to save a flight suddenly just degrade? What happens when they leave the crew completely exposed in the middle of a violent storm? On May 11th, a routine descent was violently interrupted, changing the fate of an entire flight. Let's dive right into how an experienced flight crew was pushed to the absolute edge of their capabilities.
We really need to start by looking at the atmosphere over Cape Town on that fateful day. According to the official air traffic control logs, quote, a number of aircraft had executed missed approaches owing to weather conditions. Now, if you follow aviation, you know a missed approach isn't just some minor inconvenience. It's a serious maneuver. It happens when veteran crews look at the situation and decide, nope, landing right now is simply too dangerous. And the skies over South Africa that day, they were entirely unforgiving. Relentless storms were already forcing multiple air crews to just abandon their landings and pull back up into the churning clouds. The invisible threats lurking down there in the lower atmosphere was setting a seriously perilous stage for all incoming traffic. But here's the thing, that's really only part of the story.
The real danger wasn't just that it was raining, it was the raw kinetic energy of the air itself. The sheer meteorological magnitude of this storm was absolutely staggering. Airport data shows the area had been battered all day by violent wind gusts that were frequently exceeding 50 knots. To put that into perspective for a second, a 50-knot gust is almost 60 miles per hour. Imagine trying to land a 60-ton aircraft moving at relatively slow approach speeds and getting slammed by that. A gust of this magnitude can completely destabilize an aircraft's carefully calculated aerodynamics. It literally shoves the plane off its intended path. So we're not talking about breezy conditions here. This was a highly energetic, hostile environment systematically testing the limits of every single aircraft that dared to descend into it.
Yet, right in the middle of this atmospheric chaos, one specific flight was making its way toward the threshold. Before the crisis hit, everything was perfectly routine. We're looking at a South African Airways Airbus A320, registration ZSSZ, operating a standard service from Johannesburg to Cape Town. According to the French Investigation Authority, the BEA, and their South African counterparts, the crew was acting with absolute professionalism. Anticipating the rough air ahead, they secured the cabin early. They completed a flawless initial descent, flew the downwind leg without a single issue, and even entered a holding pattern just to carefully consider their options and wait for an opening in the weather. Shortly after, ATC let them know other traffic had resumed landing. Thinking the worst had passed, they accepted clearance for their base heading. They were perfectly positioned. But what happened next surprised many observers, and it absolutely shattered that brief illusion of safety.
At precisely 6,000 feet, the trap was sprung. Air traffic controllers had instructed the A320 to maintain minimum clean speed owing to preceding traffic. Now, minimum clean speed is basically the lowest speed an aircraft can safely fly without having to extend its flaps for extra lift. It's a super efficient way to fly, sure, but it leaves very, very little margin for aerodynamic error. And while they were holding this delicate speed at 6,000 feet, the aircraft suddenly plummeted into a severe 20 to 40 knot negative wind shear. This wasn't just a bump in the road. It was like an invisible, violent hand pressing the entire aircraft toward the earth. The plane was suddenly losing the very air it needed to keep flying.
To really grasp the physics of this moment, think about a normal approach. Usually, a steady headwind flows over the wings, generating consistent lift that keeps the aircraft suspended perfectly on its glide path. But in a negative wind shear, that vital headwind suddenly just vanishes, and the airspeed over the wings vanishes right along with it. Without airspeed, lift is instantly destroyed. So, at 6,000 feet, gravity started ripping control away from the pilots as the aircraft rapidly approached an aerodynamic stall, which is when the wings completely stop flying. But hold on, because the aircraft's automated systems were about to violently intervene to save the plane, and they were about to trigger a sequence of events that literally no one in the cockpit could have predicted.
To understand how the aircraft fought back, we really need to talk about alpha floor mode. You can think of alpha floor as the aircraft's ultimate hard-coded survival instinct. When the flight computers sense that the angle of attack is critically high and the plane is quite literally seconds away from falling out of the sky, the auto-thrust system basically bypasses the pilots entirely. It screams for maximum engine power, what we call TOGA, or takeoff/go-around thrust.
When the A320 felt the floor dropping out beneath it in that negative wind shear, the alpha floor instinctively engaged. It threw the engines to their absolute maximum limit to physically muscle the plane out of the stall. The computer was doing exactly what it was designed to do: save the aircraft. But human action was also desperately required here.
As the engines roared to life completely independently, the human element reacted with incredible discipline under some extreme life-threatening pressure. The first officer was flying what's known as a monitored approach. Instead of panicking as the aircraft plummeted and the engines unexpectedly surged to max power, the crew immediately selected the flaps 1 configuration. This physically extended the wing flaps down to 18 degrees. Why is that absolutely crucial? Because extending the flaps instantly changes the shape of the wing, generating a massive, immediate boost of much-needed lift to help the aircraft claw its way out of that descending air. They were doing everything exactly right. However, an even bigger challenge remained. The interaction between their physical inputs and the computer's desperate, automated response was about to overload the entire system. What happened next was a cascading crisis that unfolded not in minutes but in mere seconds, actually milliseconds. Let's break it down. At 6,000 feet, the invisible hammer of the negative wind shear strikes. Milliseconds later, the alpha floor engages, slamming those throttles forward to save the plane. But immediately after this super aggressive automated maneuver, a critical error occurs deep within the aircraft's electronic brain, a pitch fault. And the terrifying result of this tiny electronic disagreement? The autopilot completely disconnects. The automated rescue attempt instantly triggered a brand new mechanical crisis. Just as the aircraft was fighting its way out of a stall in the middle of a massive storm, the robotic co-pilot just gave up and handed full control back to the shocked human crew. Specifically, the aircraft suffered an elevator aileron computer pitch fault. Now, in modern fly-by-wire aircraft like the Airbus A320, the pilots don't mechanically move the flight surfaces with heavy cables anymore. They send electronic signals to computers, which then move the hydraulics. When the elevator aileron computer experienced a pitch fault, it basically meant the system detected an anomaly it couldn't resolve during all those violent maneuvers, so its safety protocol was to just shut itself down. This caused the total instantaneous loss of the autopilot. The real reason this is so terrifying is that the crew was now completely unable to re-engage any of the automated systems. Poof! The safety net vanished in the blink of an eye. The pilots were suddenly thrust into manual control of a 60-ton jet in the heart of a violent storm, yet the most important detail was still to come, because the atmosphere wasn't finished with them yet. Escaping the stall actually dropped them directly into a devastating secondary threat. Remember the alpha floor that commanded maximum thrust, and the flaps the crew extended for that extra lift? Well, just as the plane accelerated out of the danger zone, the atmosphere flipped. The negative wind shear was instantly replaced by a massive positive wind shear, a sudden violent increase in headwind. So now, picture this. The aircraft has maximum engine power, extended flaps, and a massive wall of wind hitting it right head-on. The aircraft accelerated violently. The crew, instantly recognizing the immense danger of flying way too fast with flaps extended, immediately commanded the flaps to retract. But the kinetic energy was just too immense. The flight deck alarms began absolutely screaming with an overspeed warning. They had gone from literally falling out of the sky to nearly tearing the wings off from excessive speed in a matter of seconds. As the crew fought the overspeed and the brutal turbulence, the aircraft's computers systematically began to surrender. The Airbus flight system operates under fundamental laws. Under normal law, the flight computers provide absolute protection. They will physically prevent the pilot from rolling the plane too far or pitching up into a stall, no matter how hard the stick is pulled. It's foolproof. But, due to the computer faults triggered during the wind shear, the A320 degraded into alternate law. Simply translated, this means those protective safety boundaries were now severely degraded. The computer was effectively telling the pilots, hey, I am no longer protecting you from yourself. You are totally exposed. The aircraft becomes way more sensitive, much more raw, and it demands absolute precision from the humans at the controls.
The climax of this approach requires incredible human endurance. The crew is now manually wrestling the A320 through the stormy, turbulent Cape Town approach in alternate law. Every single gust of wind requires a manual correction. They are fighting the aircraft down through the weather, and as they approach the runway, they have to perform a standard procedure, extending the landing gear. But here's the catch. In this already compromised state, the very act of lowering the landing gear systematically forces the flight computers to shed the remaining complexity. Extending the gear triggers the final, lowest possible state of flight automation. The system downgrades once more.
They had entered direct law. This is the absolute stripping away of all digital interpretation. Direct law means raw, unassisted pilot input with absolutely zero computer safeguards. It is a one-to-one physical control of the aircraft surfaces. You move the stick an inch, the control surfaces move exactly an inch, with absolutely no computer dampening the movement for smoothness or protecting against overcorrection. It is exactly like driving a high-speed race car on ice and suddenly having the power steering and traction control violently ripped away from you. The ultimate safety net was gone. The computers had done all they could, and now the pilot's own hands, their raw airmanship, and their years of training were literally the only things keeping the aircraft in the sky.
But despite the violent negative wind shear, the automatic engine surges, the cascading computer faults, the overspeed warnings, the degradation into alternate law, and that final brutal transition into direct law while fighting a storm, the crew executed a safe, manual touchdown at Cape Town. The final metrics are just astounding. 0 injuries, 0 damage to the aircraft. It is an absolute triumph of human skill. The French Investigation Authority, the BEA, alongside South African investigators, are still continuing to review the data to understand the exact electronic nuances of the failure, but the physical outcome is already written into aviation history as a masterclass in crisis management.
This single event forces a powerful question that ripples outward to the entirety of human progress in aerospace. When the world's most advanced computers degrade to their absolute limits, is human intuition our ultimate failsafe? We build these incredible machines to protect us, layering code upon code to conquer the skies. Yet, as the Cape Town Windshear proves, nature can still overwhelm our finest digital armor in a fraction of a second. In those terrifying moments, it isn't the microchip that saves the day. It is the human heartbeat, the disciplined training, and the steady hand on the stick. The success of this crew doesn't just validate their training, it shapes the future of how we understand the vital partnership between human and machine. Now, attention turns toward the next phase of aviation design, where the lessons learned from this single flight could shape the future of flight control systems forever. Keep questioning the mechanics of the world around you, and I'll see you in the next explainer.